So good morning, everybody. I wanted to discuss with you this concept of an annuity and how to get the present value of an annuity. I am looking at slide 45, I believe, here. And as such, you can see they show a very general equation here of how to get the present value of an annuity. Now, as it's stated here, an annuity is a constant cash flow, and the period doesn't change, and neither do the cash flows. Everything is constant at regular intervals, okay? And so it's like a 401k, or you may have, like TIA, CRAF, or you may have one at work where you put constant cash flows in. Now, as I said, the present value of this annuity is similar to getting a lump sum payout of lotto. You get lotto and you get a lump sum payout up front. All right, so there's an example here where you put $100. You have $100 in the bank and you get $5 in interest, and you take it out, and that's similar to an annuity, right? Your $5 payments, right? 5% of 100 is $5 every year for 20 years, and they show you a lot of different slides here. And a lot of, I don't know, to me it's very cumbersome what they're showing you. And I think it's a lot easier if I show you how easy it is to do this simply with Excel. So again, they go through this extra math here, and they come up with that the present value of $5 a year for 20 years is going to be $62.31. Okay, so again, here's all the general equations, and you could go through this, but there's really no need for dealing with that. So as I said, let me go back here a little bit, and let me bring up Excel, and I'll show you that how easy it is. If I take over here, I took the present value function, as you can see, and I put 5% interest, 20 years, and a payment of $5, and here it is. Here's your answer, $62.31. So without any equations or any complexity, here's basically the present value that they went and calculated with a very large equation with multiple slides. Okay, and another one here is, I believe this was another example in your book that they did, and let me bring that up to show you. I'll bring that up to show you. Is, I believe, right over here is here's the present value of a lottery prize, right? A $30 million lotto, right? And you get $1 million a year, or do you take $15 million up front? And the interest rate is 8%. Right, so they go through all this, these slides and these equations here, and it comes up that the present value of the lotto payment comes out to $12.16 million. So you'd rather take the $15 million up front than the $12.16 million. But again, they go through all this complexity of calculating it, and there's really no need for that. And as I'll show you in Excel again, and here it is, and I just used the present value function, and I'll bring that up, and here's all I did. 8%, 30 years, $1 million a year, and it's, now you notice I put a 1 in type. 1 in type means that the payments are made up front. It's a annuity due, which means the payments are made at the beginning of each year instead of at the end. If this was a 0, the payments would have been made at the end of the year. So this is a new thing. I don't know if I showed you. I'll click on it, and you see what it says here. Type is the logical value payment at the beginning of the period equal 1. Payment at the end of the period equals 0 or omitted. So anyway, so you can see how easily I got the answer there. So again, all one has to do is throw 3 numbers in boxes here, maybe put a 1 here to tell you it's at the beginning of the period, and you're done. And you're basically done. Now, one other thing I did want to show you is I used an alternate way to get this $62.31. And what I did is I use the NPV function, and here's the NPV function, and you'll notice I put a 5% rate, but I listed each $5 payment 20 times, and you can, if you go down and scroll down on this, you can clearly see how I listed each $5 payment for 20 years individually. Okay, so you can see at the end it comes out to exactly $62.31 again, just as it did over here. Now the only difference is you'll notice this one is negative and this one is positive. And why is that so? Because NPV assumes that you're going to have your cash flows minus your initial investment, and the rule for net present value is as follows: if the cash flows are greater than your initial investment, then you do the project. So here they have to make this positive and then subtract off the initial investment. If this was being left as negative here, if this was left as negative, then you would have a problem with the fact that you would have two numbers that were negative being subtracted. So basically, this is turned into a positive number, such that net present value does the math correctly, and over here you can see that present value leaves it at negative, because they're not going to basically subtract anything. So once again, you do get the same answer, as you can see, but one is left negative and one is left positive, for that subtracting of that initial investment. All right, so I just wanted to make you aware of that and how easy that all is. And let me just go back here to the slide for a minute. And they have financial calculators, and later on I will do this future value of an annuity, and then we'll in a similar fashion I'll just simply use Excel, and you'll see we won't have to look at any of these equations whatsoever. Okay, I hope everything was clear. If not, send me an email.